Learning objective 3 is isocost. So we had isoquant to get to quantities of output. Now we're going to move to isocost, which are combinations of labor and capital to get us the same cost. And the relationship is pretty intuitive, I hope. Is the wage rate times the amount of labor we use plus the rate that we pay for capital, for rent and capital, times the amount of units of capital we use equals the total cost, right? So cost equals the cost of the labor we bought and the cost of capital we bought. If we rearrange the terms, we could state it in terms of K because our graph has K as the vertical axis. So this is just a little bit of algebra to isolate K with respect to the other variables. How do we interpret the isocost lines? On one isocost, all combinations of K and L yield exactly the same cost, right? Isocost. And as we move from one isocost to the other, the cost is changing up or down depending on the direction of the move of the isocost line. Let's just see how that looks. So this is an isocost where at 0 for L, we have this amount of K. So we take our total cost divided by the rate for K, and that is this intercept because we spent all our money on capital. On the other hand, we can go spend 0 money on capital and all the money on labor, in which case this point is the total cost that we have divided by the wage rate. So this is how much in terms of units of labor we can afford. That's just a straight line between those two, which represents this isocost. So at a given C, we have this straight line that represents the isocost. That's our base case. So let's see what happens if we change our costs. Here we were before, which is C0, and we're moving more money. So if we're allowing ourselves a bigger C amount, then we can buy more of capital or buy more of labor or any combination in between. So an isocost moves in parallel fashion, up for more money, down for less money. Now, the other change that we see is let's hold C constant. So we're not changing the budget per se, but the rate of cost went up. So here, the wage rate before was here at wage 0. And if the cost of labor goes up, all of a sudden we get less labor for it, right? So our amount of labor that we can buy will move this way. So we can only buy C divided by now a higher amount, wage number 1. So that the curves move this way, but it's pivoting on here. Notice that here, this doesn't move because the rate for capital was the same. What changed was the rate for labor. So we get this kind of shift. So now we can see some rules that we can operate when we're looking at managing cost. So here's the rule. We would produce at a level of output where the marginal product of labor per dollar spent equals the marginal product of capital per dollar spent. And that's expressed here. Marginal product of labor divided by the wage rate equals marginal product of capital divided by the rental rate. And the reason this has to be true is if they weren't equal, then you would move your resources into the other direction. And so equivalently, we could just rearrange terms again to say that the ratio of the marginal product of labor to capital equals the wage to rental ratio. We'll look at this exercise for cost minimization. And let's say Terry has a lawn service that rents mowers to people in the neighborhood. He has 5 push lawnmowers and 2 large riding mowers. And the marginal product of the small mower is that we can have 3 lawns per day mowed with the push lawnmower, and we can have 6 lawns per day from the large lawnmower. And the rental cost to Terry for the small one is $10, and for a large one is $25. So the question here is Terry's lawn service utilizing their mowers at a cost minimalization manner? And hint here is we're going to look at this relationship. The marginal product of the small divided by the cost of small should equal the marginal product of the large divided by the large. And let's see if that's true. So let's go to Excel. Here we have the same data on the left, and we're going to ask some simple questions to walk us through it. What is the marginal product of a small mower per dollar of cost? So let's just say, so marginal product divided by the cost equals, and here we know that the productivity of the small one is 3 and the cost is 5. And let's do the same for large. So the marginal product per cost, this time for large, and that equals, we can do 6 lawns a day, but the cost is 25. So it's 20. Are we cost minimized? The answer is no, right? Because the marginal product for the small is greater than the marginal product for the large. And our recommendation to Terry would be, let's start de-emphasizing the large and move toward the small because it earns us more money.